So what we've been doing recently is been looking at factorising and expanding quadratic expressions. But this is where I want to come back to the difference between simplifying and solving. Freya, what did you write for that first one there? The difference between simplifying. Wasn't too sure? Can someone help her out? The difference between simplifying and solving something. We've sort of talked about this before really briefly.
Simplifying is making it less complicated.
Yeah, that's a great answer. Simplifying and solving is like finding a value for something, right? Let me give you an example, right? Yeah, finding an unknown. If I have like y outside of y minus 2, like I could expand that expression. But I'm not really doing anything with it, right? But if I had y outside of y minus 2 equals to 0, once I introduce that equals 0 to the other side, I'm actually going to try and do something with it. I'm trying to find what values of y make this true. Okay, so that's the difference between simplifying and solving. Simplifying is just rearranging things. Solving is I'm trying to find something unknown. I'm trying to find it, and that's exactly what I'm going to look at here. I'm going to be solving these expressions. Here I've got x squared equals to 49. Here I've got x squared equals to 625. Abby, did you have an answer for that first one? X equals 7. And Maddie, did you have one for 25? Okay, let me just pause there. There is nothing wrong with these answers, right? Anytime we look at solving things, I've always taught you, think about opposite operations, right? Okay, if I have x squared equals to 49, really I'm looking for x, so I want to do the opposite of squaring, which is just square root, right? So I square root both sides, that would become x, and that would obviously become 7. Same thing here, it's just a big number. We can still square root it. It becomes 25, sorry. But here's something that you might not have thought of before, right? With quadratic expressions, they're special, okay? Because there's actually another answer to this question. And think about it carefully. This is just x squared, right? So I want something times something to give me 49. And 7 clearly works. 7 times 7 is 49. But there's actually another answer to that. There's another answer to that. Have a look at this really carefully.
-7.
Yes. Can you see that? Because a negative times a negative gives me a positive. So, if x is equal to -7, I'd have -7 all squared. That would still equal to 49. So here's a little thing that we have to look at and be careful when we're looking at solving quadratic expressions. Anytime you apply that square root as a kind of operation, you actually have to put plus or minus in front of it. So how I represent that is you put a plus or minus in front of the number. So can you guys see that there, right? When we're looking at quadratic expressions, there's actually two solutions to this equation. Usually I'm just used to solving like, x minus 1 equals to 0, x would equal to 1. But with quadratic ones, they're special. There's often two solutions that will work. Okay, so just be mindful of that. This is something a bit abstract, but I don't know if anyone had to think about it. If I have two numbers, let's call them A or B, and then multiply to equal to 0, what do we know about A or B? That seems a bit strange, but yeah, Maddie?
One of them has to be
Good. One of them has to be 0.
x is 0.
One has to be
No,
0.
in the first one.
Now, think about why that might be, right? Well, I know that if I want something multiplied together to equal 0, well, obviously there has to be a 0 involved, right? 1 times 0 is equal to 0. 0 times 1 is equal to 0. Or anything times 0 is equal to 0. In this case, I don't actually know whether it's A or B. The way I would write that is I would say A equals to 0 or B equals to 0, just like that, okay? So I would say that, what do we know about A or B? Well, either A equals to 0 or either B equals to 0, okay? Any questions about what I did there, okay? Just a preface of what we're looking at today. We're going to be looking now, after we've looked at factorising and expanding, we're going to be looking at solving quadratic expressions. And I think when we're just simplifying them, we're just kind of going through the motions, and it doesn't seem like there's a real purpose to it. I showed some of you guys before, and those of you here on Friday, I hope you might have done one of these activities, right? But when we graph these quadratic expressions, okay, I actually get what's called a parabola. Okay, and we see parabolas every day. You see them when you play Angry Birds. You see them like on satellites and stuff like that. Okay, so quadratic expressions, solving them in particular, is just a very useful skill that we need to do. Okay, so we know how to solve these linear ones pretty easily, right? But how do I go about solving these quadratic ones? I actually want to combine a whole heap of this knowledge here. Let's look at this expression here. We've got it in the factorised form. Okay, but look very carefully at this expression. Okay. When you see these brackets, there's kind of like an implied operation between them. what is that implied operation here? Between these brackets. Remember when I said think about brackets, what do you think about usually? Multiplying things, right? Yeah. So between these two expressions, there's actually a multiplication symbol. I know it's x minus 2 multiplied by x minus 1 equals to 0, right? And then, so think back to this question 3 here, okay? If I have something times something is equal to 0, I either know this is equal to 0, or either this is equal to 0. How I'll write that is I'll say, x minus 2 is equal to 0, or x minus 1 is equal to 0. Okay? So two cases here. Either x minus 2 is equal to 0, or x minus 1 is equal to 0. But when you look at it, these two, they're actually just linear equations, aren't they? Once you have them in this form, again, think about opposite operations. If x minus 2 is equal to 0, I know then x is just equal to 2. If x minus 1 is equal to 0, that's just a linear equation. I know x is just equal to 1. Okay? So, let's just recap what I just did here. I had a quadratic expression. I know that I have two expressions multiplied by each other. And because I know that either one of them has to be equal to 0, I can just break them up into those two cases. Either x is equal to 2 or x is equal to 1. And again, you can still check this answer, right? If you replace x with 2 in here, you'll get 2 minus 2, and that's just 0. So 0 times that whole thing would equal to 0. Or your other possibility is x is equal to 1. And if you put that back into this expression, this part here would equal to 0, and it would be 0 times x minus 2 there, and that would equal to 0 there. Can you guys see that, right? We've got two solutions to this now. Compared to our linear ones where there's only one, with quadratic expressions, I can actually have two. Okay. Let's look at this next one. Same idea, right? It actually doesn't matter what's in these brackets. All I'm doing is applying this idea here about thinking, okay, if I have two things multiplied together to equal 0, one of them has to be 0. So again, I've got my two cases here. Either x minus 1 is equal to 0, or, what's my other possibility?
Minus 4.
Yeah, x plus 4 is equal to 0. Okay? And then, so I can just rearrange again. X is equal to 1, or x is equal to minus 4. Now, I think, James, you saw that you could see straight up that that's going to be minus 4 as a solution. You don't have to necessarily write this whole thing each time. Sometimes you'll be able to see, as you get quicker, I can just see, obviously, x will need equal to 1, or x will equal to negative 4. That's what makes that 0. I'm just showing you all the steps that I would write out when I'm doing these for the first couple of times. Okay. And yes, can you help me out with this next one? What do I need to do?
X plus 3 equals 0.
Yep, so x plus 3 equals to 0, or x minus 2 equals to 0. And then so x equals to minus 3, or x equals to 2. Awesome. Just into the next one here.
X minus 5 or x plus 4.
X minus 5 equals 0, yep, or x plus 4 equals 0, yep. And so x would equal to 5, or x would equal to negative 4. Okay.
Ready? See if I got
Easy. Now, this one is a little bit trickier, okay? What's different about this one?
There's 2x.
Yeah, there's a 2x minus 7 now, okay? And like I said before, right, it doesn't actually matter what's in the brackets, I still always apply the same idea. Two things multiplied together, okay, one of them has to be equal to 0.
X minus 7 equals to 0.
Yep, that's exactly right. And I know this can throw you off, right? But remember, it's the same idea. Hang on, these two things multiplied together have to equal to 0. So either 2x minus 7 has to equal to 0, or x plus 6 would equal to 0.
Only one has to equal to 0, right?
So this is the thing, right? With quadratic expressions, we have two solutions. Usually with those linear ones, we only have one solution. They can either one of them are true, but we need to write both of them. Yeah.
Why do you have to write both?
Because there's two solutions, right? It's kind of like, I don't know, like alternate universe. Maybe in one universe it's whatever this one is. Maybe in one universe it's whatever this one is, right? It's different because quadratic expressions are special. There are two solutions within them. And same idea. This is just now a linear equation, right? You can rearrange it to solve it. 2x would equal to 7, or x would equal to 7 on 2. Or same idea here. X is just going to equal to negative 6, like that. Okay. So even if there is a coefficient there, we can always apply that same idea. Now this one's funny because because when you get in the habit of writing out, one thing multiplied by another, one of them must equal to 0, like both of them must equal to 0. So I think someone may get into the habit of saying, okay, x minus 6 is equal to 0. Oh. But then you see what's here and it's like, What's that? It's a 2. 2 is equal to 0? But that's not right, right? That doesn't make any sense. It's just a trick question, right? It's just making you see this method actually still works. X minus 6 equals to 0 and x equals to 6 is actually a solution, okay? But this is actually just a linear equation. This is just actually a normal equation. If you expand it back out, right, you'd get 2x minus 12 is equal to 0. And then you can just write that as a linear equation. 2x equals to 12 or x equals to 6. Just like I got over there, okay? But obviously 2 is not equal to 0. That's not something that's true. That's just a number, okay? So that doesn't apply. It's just to show you that, yeah, that method can still work. I can still say that x equals to 6 is a solution by using this method. But because it's a linear equation, because there's a single power of x, there's actually going to be one solution to this equation there. So it's just making you be aware of what's actually, what actual methods you need to do. You don't always necessarily need to apply this method.